Hey guys, welcome back. So in this video, let's talk about ML. So the machine learning is actually part of the data-driven AI systems. So usually, this is how in the older days we used to create AI systems. Uh, we want to send in some sort of input data, and then we have to put in some sort of programming logic into that, and then using using that this model is going to give you an output defined by the rules. So this is how a traditional program used to work as a AI system. But now we are expecting something else, a very different expectation. So we're going to give the data as well as the output that I'm expecting. So this is a bit interesting because output was supposed to be expected at the end, but we are going to give uh, all the data, and this is the expected output. Now I'm going to ask the machine to actually understand what is the reason behind this input data to actually give this a specific output. So we should understand what makes the input a stand out to an output. So all these relationships and all the trends and all the mappings have to be derived by the ML system. And how the machine learning system is going to do that? So we have a lot of learning algorithms, and all of those algorithms are actually classified into three ways. The first one we can see here is the supervised learning. So in supervised learning, so we're gonna give the data. I'm gonna provide you with the data, as well as I'm gonna give you the desired output that I want the machine to give. So using this, the machine using an algorithm is going to do the processing, and it is going to understand what's the relationship between the input and the output. So using that relationship, which was found by the machine, it is going to it is going to create a, a flow a flow which is going to be used by it for the other testing examples, and it is going to give you the output which is desired, which is expected, as we have already given the output. So we're gonna check if the output which is actually needed to be given, if it is the same as the model's output, then we can say whatever the algorithm that we used was able to learn about the input data patterns which are mapped into the output patterns. So this is about the supervised learning. So here we are going to give the outputs. So we are going to ask the system to understand the outputs, and there is actually another way that, so we're only going to give the data, and I'm not going to give you the output that I'm expecting, but I want the machine to understand the closeness of the input data. There could be a lot of input data, but a specific parts of it might be very close to each other. They might have a similar characteristics. Then I want the model to sort of understand those characteristics, and provide a grouping of those of those closely related objects as the output. So this is the unsupervised learning. And then we have the reinforcement learning. In reinforcement learning, the model is nothing but the agent. So it's also just another software program. So the agent is going to be placed in an environment, and the agent needs to explore the environment. And while exploring, at each and every step, we are going to give either a reward or a penalty to the agent. So based on the reward and the penalty that it received, it has to understand what is the right steps to be taken to actually finish the task. So this is how the reinforcement learning works. So let's see a few important algorithms of ML. So we have, the first thing is this is the regression. So a linear regression is actually a statistical method which is the first machine learning or artificial intelligence algorithm which was able to give the user an understanding of what AI system could predict. So uh, but how does this thing work? So here, we have a lot of data points, and then we are and then we are supposed to predict, some new uh, an, an, a new point. So we are supposed to predict what its value could be if it was given as an input. So everything on this x-axis, it can be seen as the input, and everything on the y-axis can be seen as an output. So if this is the case, then in what way I can assume that at some point at this position is going to be mapped onto which point on this axis. So to form such a relation, so we're going to plot them, and we are going to create a line which is going to represent them instead of all this data points. Yeah, but how can we understand which is the best line of regression? For that we use the algorithm. So what the algorithm is nothing but, initially it is going to find all the distances between the line and the actual point. So it is going to sum up all these distances, and it will try to minimize the error. How will it be minimized? So let us say I have a one line here, this green line, and I have a blue line, then I have a red line. So if I were to calculate the distances of each point from the green line, I'm gonna get a very big number, which you can see in this gradient descent. So I'm gonna get a very big number like this. Okay, and if I use red, so here again I can see there is a lot of deviation from all this actual points and the line. So again I'm gonna get a very big a very big number on the y-axis. But when I use the blue line, I can see that it is actually fitting the data well. So it is going to give me a much lesser errors. So that we can initially using this using us a small variation of the angle of the line, so we can reach a global minimum. And then we can see that minimum, whenever we reach a minimum, so we can assume that line as the best fit line for that model. So this is the algorithm, and this is how it's going to calculate. So we're gonna subtract the predicted and the y of a. So this is nothing but the line equation. So we're going to see uh, we are going to sum up all the errors, and we're going to see which line of equation is actually giving you the least error, right? And then we have the classification. So classification works in a similar way, but a regression is used with the input which has all numerical data. But when we are dealing with some sort of categorical or character data, the, uh, then we're going to use this a classification. So classification is nothing but, it is very much similar to the rule based systems. So using the input data, it is going to understand some sort of a trends or patterns, and it is going to create a tree-like structure. There are actually many algorithms inside the classification. So all these algorithms are going to create some sort of separation between the input values and the output values. So using those groups, we can easily identify if a new input could belong to which of the group. And then we have clustering. So clustering works in the same way, but here we are not gonna provide the output. Uh, that means that we don't know that if all of these three of all of these are actually a same group. No, we don't have such information, but we have to understand what kind of characteristics are exhibited by the input data, and using that we have to group them together using the own algorithms. So after applying some sort of algorithm, the mod is going to identify a number of groups in the data. So this is how the clustering works.